Hi, in this video we are going to talk about the so-called counting sort, so let's get started. Counting sort is an algorithm for sorting a collection of objects according to keys that are small integers. It's very important that counting sort is efficient for only small integers. If there are integers such as 1,000,000 or much greater numbers, then this algorithm we cannot use this algorithm efficiently. It operates by counting the number of objects that have each distinct key value and using arithmetic on those counts to determine the positions of each key value in the output sequence. We are going to see it in the illustration. It is only suitable for direct use in situations where the variation in keys is not significantly greater than the number of items. So we have small integers 1, 2, 3, 4, 5 and we have several ones, for example, several twos, threes, and so on. We can use it as a subroutine of radix sort. Radix sort is a better algorithm for these kinds of problems because it can handle larger keys efficiently. And it is not a comparison sort, so the n log n lower bound for comparison sorting doesn't apply to it. For sorting algorithms, the lower bound is usually this n log n for such as heap sort, merge sort, quick sort, but for these algorithms we always compare the items, and there are algorithms such as the radix sort or this counting sort for which we doesn't have to use these comparisons, and it has a ordo n plus k running time where n denotes the number of items you want to be sorted and k is equal to the number of buckets. What are the number of buckets? I'm going to talk about it later. So we have an input 3, 1, 4, 1, 3, 5, 4. We want to sort this array and we have 4 buckets because we have ones, we have number 3s, we have 2 4s, we have 1 5. So there are 4 distinct integers in this situation, and that's why we have 4 buckets. So when I said that the running time of the algorithm, the running time of the algorithm is ordo n plus k, this k denotes the number of buckets. So in this case we have 1, 2, 3, 4, 5, 6, 7, so n is equal to 7 and the k is equal to 4. This is the number of buckets. And we just iterate through the input and increment we initialize the buckets to be 0, and we iterate through the input array and keep incrementing the numbers in the buckets accordingly. So it is a 3, so we keep incrementing the second bucket, then a 1, so we keep incrementing the first bucket, then we keep incrementing the third bucket, then it's a 1 again, so it's going to be 2 in the bucket, then a 3 again, so it's going to be 2, then this is a 5, so we change it to 1, and another 4, so we increment it to 2. So after iterating through, iterating through an array takes linear time, and that's why it is approximately linear time complexity, this algorithm. Here we just have to get the solution because we just have to iterate through the buckets and print out as many of the given buckets associated with the given bucket as the number representing the bucket. So for example, we have 2 in the first bucket, so we have to print out 2 1s, and we have 2 from the number 3, we have 2 from the number 4, and we have a single 5. So that's all about radix sort. I think it's quite easy to comprehend and understand the basic concept of this sorting algorithm. In the next video we are going to talk about the much more efficient radix sort. Thanks for watching.